Hi, good afternoon, everyone. Thank you for attending this webinar about building information modeling, transforming renovation in the construction industry. Today we will talk about what is building information modeling, what tools can you use, and how do you gather data. We have several presentations today about a few of our project partners of the InCUBE project. But before we start with the topic itself, I'd like to very briefly introduce the agenda. So I will give a very brief introduction of the different speakers we have here today. A very nice presentation, short presentation about what is InCUBE, what is the project. I'll do this very briefly. Then we will dive into what is building information modeling itself, go into the different tools and technologies that are available, and then towards the data gathering, because it's all about data. And at the end, we have a nice BIM case study where we will look into an example of how BIM is used. At the end, we have a Q&A, so please feel free to ask any questions in the chat, and we will try to answer some of them at the end of the webinar. The speakers of today, my name is Philo Tamis. I work for New Energy Coalition. New Energy Coalition is one of the 23 partners in the InCUBE project, and we are in charge of the communication and dissemination activities, such as this webinar, to really share the best practices and knowledge of the InCUBE project towards the rest of the world. Then we have Beatriz Frontera from Metro 7. She's the CEO architect. Guillermo Martinez from Wijnen, and BIM director, and Elisa Ferrella from FBK, a researcher regarding everything around BIM. About the InCUBE project, InCUBE is a project that stands for an inclusive toolbox for accelerating and smartening deep renovation. It aims to industrialize the renovation process of existing buildings, because a large amount of the current building stock in Europe is not set for the current standard regarding sustainability. So what this project is trying to do is try to come up with standardized, integrated processes, different technologies, different tools. How can we speed up the renovation of EU's buildings? And we do this in 3 different cities: in the city of Groningen in the Netherlands, Trento in Italy, and Zaragoza in Spain. Here's the map of the different partners that are involved in the project. 7 European countries in total, with 3 different lighthouses in the Netherlands, Italy, and Spain. We started in July 2022, and the project ends in June 2026. And in total, we received over 8 million euros of funding from the European Union. And the other 2 million is funded through the partners itself. The key expected outcomes of InCUBE are illustrated here. So first of all, we try to reduce the waste streams that are caused by renovation processes. We try to reduce the cost of renovation and also the hazardous activities where workers are actively working on every day. We try to close the energy performance gap, reduce greenhouse gas emissions, energy savings, of course, have to be increased. And we also actively involve the citizens of the cities and of the buildings. The problem that we focus on, well, on the left you see the issues that we currently face in the construction industry and in the renovation industry. For instance, the low rates of productivity. And on the right, you see some of the solutions that we will implement in InCUBE to tackle the problem at hand. Besides the first one, there's also a poor integration of solutions, so we try to improve on that as well. And there's limited information on the building life cycle. We have different software, but also hardware technologies to work on that. And also solve the highly complex process of a renovation of a building, because there's different stages and every stage has its own issues and challenges. And we try to integrate those. This image showcases this a little bit. So on the left, that is the current situation. It's quite a linear process. So every stage has to be completed before the next one can finish, or can start actually. And on the right, you see that these different processes are more interconnected. And that is really what we try to do in InCUBE, try to connect the different phases and try to find out what is needed to make it a more efficient process overall. InCUBE does that over 4 topics: industrialization, digitalization, new technologies and materials that are needed, and new market entrants. For example, if you look at industrialization, we look at offsite manufacturing, on-site installation, and circular construction. Different technologies that are being used are different insulation materials, for instance, for the envelope of a building, different innovative renewable energy producers, so solar tiles in the roofs of buildings, and also innovative solutions for energy storage or heating and ventilation, and district heating, for example. About this digitalization, 3D modeling, digital twins, etc., and also building information modeling, which we will talk about in more detail today. And all these more details of what was actually done in InCUBE is also available on the InCUBE website. And last but not least, this is the 4th pillar of InCUBE, which is about new market entrants, where we try to create a one-stop shop for all the different innovations that are being developed in InCUBE. We also try to improve the gender mainstreaming in this sector, because it's mostly an industry dominated by men, but we really try to involve women into this sector as well. And we try to upskill the future workforce with all these new technologies and solutions that are being developed, that they are all up to date about the new standard. That's a brief introduction about InCUBE. We will now go towards the first presentation from each studio, Beatrice. She will talk about what is building information modeling. So I'd like to give the floor to you, Beatrice.
Good afternoon. First of all, I would like to present my company. Metro 7 is the combination of an architectural firm and a construction company. And our expertise is related to efficient, helpful, smart, and comfortable buildings. In InCUBE project, our role is linked to the Spanish demo site, where we lead and coordinate the solutions that are going to be implemented on the demo site. In addition, we are going to be implementing and adapting Lean methodology through IPD, A3, and LPS tools. And in relation with the BIM methodology, we also lead within the InCUBE project, building mapping and modeling tasks. So first of all, what is BIM? BIM is a collaborative working approach to develop and manage construction projects. Therefore, even though when we think about BIM, we think about 3D models, BIM is much more than that. BIM is a methodology to create, integrate, and handle design, construction, and operation building information through a digital representation. This methodology can take into account project's complete life cycle. This is from building ideas inception up to the end of life of the building. In the case of InCUBE project, we are working with existing buildings where renovation works are going to take place. Hence, our starting point is the data gathering of current state of the building. In order to obtain geometrical information, we have been working with point clouds coming from laser scanning and UAV flights, as my colleagues will explain afterwards. All of the data contained in the model will be used in different project stages and will feed a dynamic digital twin. So, as explained before, BIM is not only a 3D model, but a digital representation that contains different types of parameters and assets to develop an architectural projects and also to help with building operation. It gives us the opportunity to merge multidisciplinary data and organize all the information at different levels. In addition, we can also move up to city level with city information modeling, which relates building information with geographic information. This is data modeling at city level, which allows positioning the building digital twins that contain all these features and parameters on a georeference map that also contains geographic data nodes. But as BIM and SIM models can contain many parameters and information, we have to organize and manage all this data. At the end, all this information has to be useful, and the first tool to harmonize modeling tasks is the building execution plan. This is a coordination document where the key elements of the BIM have to be defined. With this tool, all the stakeholders that are going to be involved in the BIM life cycle will agree on the goals and the scope of the model. It is necessary to understand why and how the BIM model will be used in order to develop it in an optimized and productive way. Also, the level of definition required is one of the first decisions that has to be defined. Although high definition projects can be developed within this methodology, we have to tailor it to the actual needs. In addition, the roles of each stakeholders, how the activities will be shared and coordinated, as well as the software that's going to be used by each stakeholder will be required in this document. But why should we focus so much on this first step? Because we need to be able to manage all the information handled in the model. We can define as many parameters as we wish and relate them to the simulations needed. But sometimes we have to keep in mind that less is more. When managing large amount of data, also information loss may happen. Sometimes when sharing information between disciplines or different software, the data that has not been properly shared, presented, or exported may be lost. Even though there is a common exportation file, the way some software read or interpret these files may involve loss of information if they have not been modeled as required. So before modeling, what we need to know is which software or which future simulations are expected. This means that maybe the way we model information will not be the same if afterwards we need to perform energy simulations or do augmented reality applications or for construction works planning. This doesn't mean that we cannot use the same model for different purposes, but that we need to know beforehand which purposes are going to be needed so that the modeling is effective. The objects and parameters introduced have to be defined as needed for future works. Also, over-information can be counterproductive if they prevent us of focusing on the important issues. This is also related with workflow in this type of methodology. Other CAD design methods require less effort at initial stages, but need further work during intermediate phases, or especially if changes happen. In BIM methodology, instead, it requires of high definition efforts at the beginning, but an easier workflow is expected after this initial design phase. But we need to understand the complete scope to find the level of definition according to the purpose and find an effort balance. As BIM is a collaborative methodology, the way we share information is vital. If we're going to work with different teams, we may have a central model where each discipline can provide their contribution working with local files, but having a holistic or a global overview of the complete project. On the other hand, through this unique central model, we can obtain different types of inputs and outputs. During the data gathering stages, for example, we can use point clouds coming from scanning, topographical surveys, or initial drafts developed with other techniques. Afterwards, once the model is ready, we can easily obtain construction plans or further work with it for simulation activities, development of a live digital twin, or for example, for operation or management activities. In order to collaborate, there is this common file typology, IFC, which allows information transfer between different types of software. The BIM model at the end is a digital representation that presents buildings geometries and allows virtual simulation and dynamic analysis. With BIM methodology, we enable collaboration between disciplines and also some automatic processes. Elisa afterwards will show an example on how automatic workflow can be deployed within BIM or this type of modeling environment. Also, the BIM cycle can be classified into 10 dimensions, which are related with the phases of a construction project. The first dimension would be the inception, the initial ideas and estimation definition. 2D and 3D are related to the geometry, and 4D introduces time variable. For cost and performance, we can manage them as the 5th and the 6th dimensions. 7D would be the development of an operation and maintenance guide, while with the 8th dimension, we can manage risk and safety. Lean construction management is related to dimension number 9, which allows process and resources optimization through the BIM model. And the last dimension refers to off-site manufacturing modeling. Afterwards, you will see how my colleague Guillermo shows some examples on how these dimensions are deployed within real projects. But also, as BIM models include a 3D representation, these models can also be used for virtual or augmented reality. However, as explained before, the modeling should be adapted to the expected uses, and therefore, detailed rendering may need specific type of modeling. Besides, it is clear that working directly with 3D models instead of 2D representations eases communication and understanding of the construction solutions. So now I will give the floor to my colleagues.
Thank you, Beatrice. Very interesting. I think this is a nice transition towards the tools that are out there and the tools that you can use for your specific needs. So once again, I'd like to thank you, and I'd like to welcome my colleague Guillermo on stage. Thank you, Guillermo.
Thank you. First, I would like to present and give a little overview of our company. Wijnen is a construction group with more than 2,400 employees with 27 branches throughout the Netherlands. And we are active in project development, residential construction, renovation, and circularity. And within the InCUBE project, we do the coordination of the Dutch demo site in Groningen. We are doing also some research about the compatibility with BIM and robots and BIM-based products. We also use a lot of tools, as Beatrice mentioned. These tools are they can be categorized in authoring tools, cloud-based apps, class detection tools, planning, and so forth. And I will go through every of these categories to show you what the most popular tools are in BIM. And some of those are used by our company. For the authoring tools, some of the most used tools are Revit, ArchiCAD, BricsCAD, and Tekla. And every tool is better at its own things than the other one. For example, Tekla is very useful for constructions or for steel constructions, and BriskCAD is, for example, very useful for combining 2D and 3D drawings. For the cloud-based applications, we use Autodesk Construction Cloud or BIM 360. Dalux is also one of these tools, and Trimble Connect is also a very useful tool for the management of a project, which are started with BIM or BIM or have a collaboration with BIM. We think we believe that BIM thrives on interoperability, and the ability of different software tools to communicate is what empowers every BIM project. So we try to combine all these tools together. For example, when we have some projects and we do the clash detection of these projects, and how we communicate these clashes. We do this also with tools that can communicate with each other. The same, we try to do the same for the planning and the management on site. And we try also to manage all the different assets on site, and we do this with open space and budget management. We do this with a software called IBIS. I don't know, maybe it's not very known throughout Europe, but in the Netherlands it's very, very common. Although cloud-based applications such as Autodesk Construction Cloud, Dalux, and Trimble Connect are mainly used for project management, and these applications are equipped with different tools. We use different tools, so we use the tools that can be combined together, that can be connected together, so we can get the most of the best of the projects. These cloud-based tools are also equipped with some can be equipped with planning tools and clash management tools and so on. But we think that with the interoperability of the different tools that are the best at its own, we can do better and be have more quality gathering the information and presenting the projects and managing this. That was.
Thank you, Guillermo. I think this is a very nice overview of the different tools that are out there. But I remember we had a discussion among the two of us where you mentioned that data is everything.
Yes.
Without data, these tools are hard to use. So thank you again. And I'd like to go to the third speaker of today, Elisa, who will tell us more about how to gather data.
Thank you and good afternoon. I will start by introducing my foundation, that is a Bruno Kessler Foundation, a public research center in the autonomous province of Trento in Italy. And we are about 600 employees working on two big research areas, so science, technology, and humanities. My research unit in particular is called 3D optical metrology, and we work on applied research in the fields of photogrammetry, 3D mapping, and geomatics. So basically all the techniques that are used to produce 3D reality-based surveying data. So 3D representation of the world at every scale, from the landscape and urban scale until the building or artifact one. And the main 3D representation that we can have from this kind of survey are point clouds, what I am showing now, and from which we can derive other products like mesh models or texture models. So in the 3D surveying and the modeling workflow, we realize 3D model, but not starting from drawings, for example, but based on 3D measurement of real objects. So starting from the needs, so the analysis of the details, the level of details that we want to achieve for our representation, we can start the planning phase, so the sensor choice that we will use for the data gathering and data acquisition. And through some processing, we can finally derive the final 3D models. Basically, we have nowadays available two main families of capturing technique. The first one is based on active sensors, and in this family we can find all the laser scanner technology. And in this case, we can derive directly 3D measurements through the laser. The other family of techniques is based on passive sensors like cameras, so we can derive 3D models simply from images. And based on the object and scene complexity, the level of detail that we want to achieve, but also the scene size that we want to represent, we have available a lot of different technologies and sensors and acquisition platforms. So starting from the farthest sensor, satellite-based data, basically, and going through the airplane or UAV or drone-based acquisitions, we can arrive to terrestrial sensors like terrestrial cameras or a different kind of laser scanners that are based on different acquisition technologies. And from this kind of data, 3D data, we can have a lot of different applications. So we can use them for terrain analysis, for example, or for solar mapping, or for 3D city modeling applications with the different level of detail. And of course, finally, also for BIM modeling. So coming to more practical examples, and what was also our experience within the InCUBE project, we were involved in all the data capturing phase and serving phase, all the processing to derive the final point cloud that was used for producing the BIM of the Trento demo site. And from this kind of model, BIM model, it will produce another model that is the BEM, so building energy models for further energy analysis. And the Italian demo site is the Santa Chiara district that comprises different building blocks, but the main focus of the intervention will be this historical building, very complex building. So we're starting the planning phase from the needs, and we decided to have a 3D representation with different level of details, in order to have 3D data more manageable within the BIM environment. And also we decided for hybrid acquisition and processing techniques using both active and passive sensor data. So the main acquisition campaign was based on terrestrial laser scanner activities. We acquired a very detailed 3D representation of the facades and the indoor spaces. We acquired more or less 360 scans and panoramic images from the same scan stations. And we then integrated this kind of data with data from an handheld laser scanner, so another laser technology. In this case, you can acquire data simply walking through the spaces, through the environments, and we decided for this solution for surveying more inaccessible part, like this one that is the under roof of one wing of the Santa Chiara historical building. And in order to complete the 3D surveying, and in particular for having 3D information on the roof and surrounding area, in this case, we decided to process some available aerial images over Trento. On the left, you can see in blue the image position, the camera positions, and data acquired from the airplane, and on the right, the derived 3D point cloud. And after some processing, cleaning, and the co-registration of this hybrid data, we were finally able to derive the final 3D point cloud that was then used for the BIM modeling, so having an accurate ground truth and reference data in all the modeling phase. And these are some results from the Trento demo sites and the BIM that was produced. And all this data, so the reality-based data, the point clouds, but also the BIM model are now shared with the research and development community in order to boost, in particular, two investigation, two tasks. The first one is to boost the development and testing of more automated procedures and algorithms for the BIM modeling from reality-based data, so what is called the scan to BIM, considering that currently this is mostly a manual process and really time-consuming. And the second task is to improve the transformation of the BIM model into a BEM model, because currently in this transformation there is an important loss of with information. And we started also to play with our data, the Santa Chiara data, with some research activities. We're starting to test some automatic algorithm of machine learning, so artificial intelligence, for the automatic segmentation and classification of the point clouds. So basically we can divide it, semantically enrich our 3D data and divide the data into clusters of points belonging to particular class. And this is quite important for the possibility to work into a BIM environment with fewer data, so single classes like walls or windows or pillars and so on, and have a more manageable environment. And we are now also developing a new semi-automatic procedure for the automatic modeling of walls from point clouds, and this will be an add-in realized for Revit. And we already developed also another semi-automatic procedure, but based on a visual programming language in Dynamo, for modeling architectural elements, decoration in a semi-automatic way. And this is particularly important when we have to model in BIM historical buildings that are rich of decorations and of small details. Of course, this can improve all the modeling process. Okay, I can leave the stage.
Thank you, Elisa, for your presentation. And now we can look at an example where everything comes together. So we now know what building information modeling is, the tools that are out there, and how we can gather data. So thank you once again, Elisa. And Guillermo will now present to us an example of a case study where building information modeling is used. And I'd like to remind all the listeners that if you have a question, please feel free to ask them in the chat, and we can check them at the end of Guillermo's presentation. Thank you, Guillermo. Good luck.
Thank you. I would like to start first with a sum up for what it means to us and what you said about data and what we believe is the most important We see here what for us the information workflow was in a traditional way when we were working with only 2D drawings, and was the change that's been brought to the company. And we see there was some data losses or some stops, and then come back again, and we can see, or for us is working with BIM and working with 3D modeling and interoperability with different partners and different tools has brought a workflow with this continuous, and the data loss is brought to zero actually. I would also like to recap some of the benefits of working with 3D modeling and working with BIM. Mostly there is a virtual model which is visual, better to check. There's not data loss. Collaboration will be high because every partner will have the same information. There is better data quality because every aspect of the model, of every information, all the information is put into the model. Coordinated approach, then also there could be a visual simulation, and benefits from BIM could be also a prefabrication, which make all the building process go faster. I would like to show you a case study. This project we did, we started last year, which was only a 3D model with no data, no or very few information in it. So we made the decision to upgrade this model and made an investment of 3,500 euros, which results in 3 weeks engineering process. We gained 3 weeks and a lot of reduced errors during constructions, which for us as a construction company are the most that the higher cost if we discover errors during construction. So I would like to go through some steps we have when we start with a project, or we go to engineering with the project, and how it goes through the process. So as I said before, we use cloud-based applications combined with other tools that are connected with each other. So I would like to share my screen first. It's not possible right now. I don't know if I have to stop the presentation, Philo. All right. Is it visible? Right. Well, when we start with projects, we created a platform in BIM 360 at this moment, and from there we give access to all the partners to upload their models, and so everybody has the same information and everybody has the same type of model we need to go through the project. There are some different modules in BIM 360, and every model has different specifications and has different tools in them. Mostly we use document management, field management, and model coordination. and all of these tools, most of these tools are connected with the other tools we use for the project management. So we use document management, and there's the place where the BIM models are uploaded, but we also have other folders where partners can upload their documents and can work together. So every is visible for every partner. From the model uploaded from our partners, we go to the next steps in our project, and that would be to check the model, look for some clashes, look for visual control, and to give the feedback to our partners if needed. So we have the possibility to use two different tools, Navisworks and Solibri, and we use Navisworks to make the clash definitions, and depending on how many clashes, we connect the clashes to BIM Collab. This way we communicate with the different partners, and the communication goes through the model, and it's not necessary to use your email or other type of communication. So there's no data loss, and then you can always go back to the platform. And there's also a online platform where you can see all the issues. If these are resolved or are not resolved, you can also make a report and share it with the partners. And then this process goes back and forth with the different partners until we get a clean model, as we call it, and a model we can build our construction with. There's also we use another different tools to gain quantities from the model. We use, for example, Solibri, and I can give you a small. I can let you see a bit where we get the our quantities, and these quantities we can combine these quantities with our project, with our budget management tool, which is also this latest development, which has also a module where you can upload an IFC model, a 3D model, and then gain the information from there, and then combine all the information you need for the budget management with your 3D model. So basically, that's our case study, and that's basically our process, starting where we get a model, and then we do a lot of checks, and we use the tools we can combine together to get the most quality out of the BIM model, and also construct and make our building with high quality.
Perfect. Thank you, Guillermo.
Thank you.
Very interesting to see how this was being implemented in practice, in real life situations, because we've seen a lot of different 3D models, but it's always nice to see an example of it. I'd like to invite all the speakers on stage so we can have a brief discussion. about some of the questions that were asked in the chat. So I will now close the presentation. So I saw two questions, two similar questions actually in the chat. One from Danielle and one from Yanis. And they both were wondering, of cost and time-wise speaking, you can imagine that it takes quite a lot of time and effort to make these kind of models. Is it worth investing time and money in BIM? And for instance, well, I guess the bigger the project, the bigger the savings are. Is there anyone that can reply to that question? Is it worth it?
Shall I?
Yeah, sure.
Yeah, all right. Looking at from our perspective, yes, of course. It was a small example, and it was not a very big project and not very difficult. But you see, in a small project, we gain already 3 weeks of engineering by making a small investment. So for us, yes, always is a good investment.
So Wijnen uses this as a standard practice, you could say.
Yeah, of course, as I said, not always we get a model with a lot of information or a lot of data that we need or we can use. So we use this model and we update it or we upgrade it with the data we need.
Okay, thank you. Is there anyone else that would like to add on that?
Yes, we could also add to cost and time savings that you reduce potential mistakes on site, and also if changes are required during design phase or construction phase, the management of these changes on the BIM model are really more or are easier and faster if you work with a BIM model than a traditional methodology.
Okay, thank you. I see that there was another question from Nate, and he was wondering how BIM can be used or how can it support the facility management and maintenance after construction. So once a building has been built, is it still, well, how can it be used?
We try to, well, the information you already have in the model. I can give you a small example. For example, is if you have a window, a wooden window that is placed this year and it needs maintenance over 4 or 5 years, you can use the information in the model, so you don't have to go through all different documents and to go back to where when the window was placed, and just use the model, and all the information is in the model. So what color is it? When was the window placed? What type of wood is it? All of this information. Also, you can, as I show in a small slide, you can combine your planning with your 3D models. So you can put timing on your elements and use that for your maintenance post construction.
Okay, so it improves actually also the maintenance of,
yes.
After construction. So that also helps with that phase. Okay, thank you. There's one other one, and I think it might be an interesting one for Elisa. Mark asks, where do you see the usage of BIM in 10 years from now?
Interesting. I think that not only BIM, but all the technologies that are available now in the future will be essential for our life, such as also artificial intelligence coupled with the BIM. I think is really the future, because now BIM has a lot of bottlenecks as it is. We have to say this. We have mostly manual processes, so it's quite hard, and also the convenience of using these models, as someone said in the chat, for example, for small houses, at the moment is not really clear. But I think that in a bigger way to think, and what we can expect in the future, they will be all integrated. That will be essential for the construction sectors. This is my opinion. Then we will see what will happen also as a technological point of view.
Okay, thank you. Someone replied to that in the chat, and maybe it's related to when you were speaking. What would be the role of AI? Probably it will have a role. I mean, it will have a role everywhere.
Of course, it can improve the automation of all the processes, but also the prediction, for example, about maintenance and so on. They will integrate, I think, for sure, all these functionalities within the BIM environment.
Okay, thank you.
Thank you.
I see that a lot of people also asked some questions, so let's see if we can answer one more. Georgia asked if you're able to have more or manage more than one project using BIM. Probably depends on which tool you are using, but is it the case? Can you use multiple projects at the same time in such programs?
Yeah, sure. You can manage as many projects as you need with BIM. There's no issue or problem on managing different projects, and even in the same project, you can manage different phases or stages. So that is really also useful for big projects or projects that require several stages for design or even implementation.
Okay. Kristalline is asking if someone could elaborate a little bit more on the open space for asset management. I think Guillermo, you presented that, if I'm not mistaken.
Yes. We are going to start with open space very soon, and you can the use of open space is like a Google Street View, for example, but then on the building site, so it registers everything. So you can combine a 360 camera, which makes every second it makes pictures, and then it records, or not records, it takes pictures of the whole place where you are at that moment. So it gains a lot of information, a lot of visual information, and you can put this information into a report and use this report with for different purposes. So if you are in a space, in a room, and you need anything from that room, the camera will just keep going, and they make a lot of pictures of that space, of that room, and then also place you on the building site at that moment. So, for example, if you have a 2D drawing where you were standing at the moment, this platform will place you there at the moment with time and date. So if you go back again, let's say 1 week later, it will remember that you were there the last week, and then see the progress of what happened during that week, and if something changed or.
Okay, interesting. I hope this clarifies your question, Kristalline. Maybe a nice question to round up this discussion about regulation and standards, and maybe also about some challenges and barriers that are there. So are there any regulations and standards currently in place for implementing or using or tracking BIM throughout Europe, or is it all just a Wild West?
I think every as I have seen within the InCUBE project, every country has their own set of rules, set of standards, and there is a standard European, I think it is a standard which we are using for the project as well, for the developing of the elements that we're going to use. But this is very minimum. And someone said about the ISO 19650, that's some European standard, but it's not used everywhere. So we know it exists, and we think it's a very good way of collaborating or working together. But it's not. I don't know if in Spain or Italy is already used throughout all projects, for example.
Okay, but it is a topic that is being looked at, of course, so everyone is aware, but we're not there yet. So maybe in 10 years' time, it's all aligned.
Yes, it's actually under development still. Many new standards or regulation are ongoing, but it's not really finished or developed or any standard that everyone agrees on implementing.
Okay. Thank you all for your elaborate answers on these questions. I think I'd like to round up the webinar about building information modeling. First of all, I'd like to thank the three of you for your contribution in this webinar. I think we touched upon some very interesting topics. Well, first of all, what is BIM? It's an interesting field. I think you could talk about it for hours, and it's just a small part of the InCUBE project. Again, thank you, Guillermo, Elisa, and Beatrice for your time and attention. And I'd like to thank also the listeners. We will upload the webinar once it has been processed. So for those who are so interested that they want to watch it again, you are able to. We will let you know. We will communicate it through our communication channels. And if you have any questions afterwards, feel free to contact us. You can find our details on the website, and then we will try to answer them as good as possible. Thank you, and have a nice day.